evening, students. Today we're going to learn how to use the microscope. Here I have in my hand is a specimen I just prepared. So notice when I use the coarse focus, and there's a coarse focus and a fine focus on both sides of the microscope. So if you're left-handed or right-handed, it doesn't matter. Notice how I can move the stage down, and then I can put my slide into place without bumping into the objectives. Now, notice how I'm using the scanning objective lens. This lens says 4x optical on it, and it's usually indicated with a red band. Now I can move the stage, I can move it up, and I'm going to go ahead and turn the light on the microscope. Now I can focus my specimen. Generally, the best way to focus a specimen is to start, and notice how I'm also moving the stage here. I want to make sure that my specimen, and I'm actually looking at it, so I'm looking that where the light is coming through where I have my cover slip. Otherwise, you're not going to see what you want to look at. And so what I'm going to do is I'm going to put this, if you look what I'm doing with my hands here, I'm changing the coarse focus so that it's as far as it can go. You see the stage moving? I want it to go all the way down as close to the sample as possible. And then I'm going to back off just a little bit, and I should be able to see my sample. Because these are parafocal, I can just simply rotate the nose piece to see if my specimen should still be in focus. The only thing I'll have to do at this point is adjust the fine focus. Most microscopes are designed like this. So now I'm in the 10x objective and I can see a little bit more. Let's see what I'm looking at. Okay, and now I can move my stage left to right. And I want to show you something. If you notice, when I go left to right, when I move the stage to the right, if you see the slide, see how the slide is moving to the right? I'm actually seeing a mirror image. So it's actually, when I look in the microscope, it looks like it's moving to the left. Same thing when I go up and down, it's the opposite. And what you're looking at is actually a mirror image. So if I were to put the letter E in here, for example, which I will do momentarily, you will see that it's actually flipped. Now that we've focused in at the 10x objective, let's go ahead and zoom even further into the 40x. Once again, we only want to touch the fine focus at this point. If we use the coarse focus, we run the risk of smashing the objective into the slide, and that wouldn't be good. Let's take a look at what we have here. There are things you can now see in the microscope that you couldn't before because of the resolution. They were just too small to see in the previous objectives. There's also a 100x oil immersion lens. However, since this is a wet mount, we won't be able to use this on here. The oil objective requires oil, and generally you would use this on a fixed slide. So we could make this a prepared slide, but because it's a wet mount and has a cover slip, you won't be able to see very well through the cover slip. It'll make it, because of something called the refractive index of the cover slip, it'll be very difficult to actually see the specimen with an oil objective lens. However, we can get a pretty good look at what's going on. This is a sample of rainwater collected from outside that has various specimens of microbes in it. And if you look here, you see these, we have several specimens that are moving. Scientists are able to identify what they see in the microscope using a key. That's what you'll be doing in the laboratory. Thanks for watching this short video.